Earlier on, we talked about the different kinds of particles. We defined atoms, molecules, and ions. We also talked about the different kinds of molecules and ions. Let's focus now more on the atom. An atom is the smallest unit of an element, and of course, as we said earlier, elements are the building blocks of all matter around us. So when you look at a structure of an atom, of course, you may have come across these pictures of atoms where the nucleus is in the center and the electrons seem to revolve around the nucleus as the planets revolve around the sun in the solar system. Now that picture is a little misleading because that picture kind of assumes it implies that it is possible to chart out the exact path that an electron takes around the nucleus. It implies that it is possible for us humans to pinpoint the position of an electron at a given moment in time. Actually, we can't do that. We are not capable of doing that. Protons, electrons, atoms in general are extremely small, and we really cannot chart out an exact path that an electron follows outside of the nucleus. So a better starting point to look into the structure of an atom may be the one that is shown on the slide, where the nucleus is the small dense body of particles in the center of the atom. It's a very small area. It is space. It occupies very small space. It has a lot of mass, and therefore it is an extremely dense part of the atom. The nucleus contains the neutrons and the protons. All the neutrons and all the protons of an atom exist in this tiny space in the center of an atom called the nucleus. Outside of the nucleus is where all the electrons are present. As I said a little while ago, as humans, we are not capable of pinpointing the position of an electron at a given moment in time. We cannot do that. They are very small and they move extremely fast. They do have a charge, so all we really can see is this cloud of charge. All we can really talk about is electron cloud, because that's all we can really see, or the charge cloud, which also implies the charge of the electrons, but as a haze all around a given space around the nucleus, all in a given space around the nucleus. So the point that I really want you to understand and remember is that the atom is made up of this central, very dense region called the nucleus, which contains all the neutrons and all the protons, and the electrons are all around the nucleus. So the subatomic particles are the particles that are present inside of the atom. There are, of course, several subatomic particles. These subatomic particles are not stable enough to exist on their own. The only way these subatomic particles can exist are with each other in a certain combination that makes them stable. And that is what makes an element is when they have a very specific arrangement of these subatomic particles. There are several different kinds of subatomic particles. We will only focus on three. We will only focus on protons, neutrons, and electrons. As I said earlier, protons are and neutrons are the particles that are present inside of the nucleus. Because they are present inside of the nucleus, these particles are also known as the subnuclear, excuse me, I can't spell today. Let me try that again. Subnuclear particles. The electrons, of course, are present outside of the nucleus. Please note that the protons have a charge of +1. Each proton has a charge of +1, and each electron has a charge of -1, whereas the neutrons are neutral, hence the term neutrons. They do not have a charge. So given this, do you think a nucleus will have a charge? Absolutely, yes, the nucleus does have a charge. What is the charge on the nucleus? The nucleus of an atom, because it contains all the neutrons that have charge 0 that are neutral, but also contain all the protons that have a charge of plus 1 per proton, the nucleus is actually positively charged. So if I asked you, what is the nuclear charge for a certain element? Basically, what you need to know is the number of protons for that atom in that nucleus, and the charge will be plus. Okay. Now, something for us to remember is, since of the three particles, protons, neutrons, and electrons, the protons and neutrons are way heavier, have a way higher mass compared to that of an electron. An electron's weight or mass is negligible, can be ignored, can be neglected. It is so small compared to the masses of protons and neutrons. And since protons and neutrons are all present inside of the nucleus is where the mass of an atom is concentrated. So when we talk about the mass of an atom, 99.9% of that mass is concentrated inside of the nucleus. Whereas the size of an atom, the radius of an atom, the diameter of an atom depends upon the number of electrons outside of the nucleus, because the nucleus is very small in the middle. Most of the space of an atom is occupied by the electrons or the charge cloud. So we do need to remember that the mass of an atom is concentrated in the nucleus, whereas the size of an atom, the volume or diameter or radius of an atom, is mostly because of the electrons in that atom. So, something else that is extremely important for us to remember, that atoms by definition are charge neutral. In other words, as soon as we use the term atoms, we are implying an overall charge of 0. Now let's think about this for a minute. How is this possible? We know an atom is made up of the nucleus in the center. Does the nucleus have a charge? Absolutely, the nucleus does have a charge because the protons reside in the nucleus, so the nucleus has positive charge. Does the space outside of the nucleus have a charge? Absolutely right. The space outside of the nucleus also has a negative charge because all the electrons reside in that space. So what will have to happen in order for the atom overall to be charge neutral? Exactly. The positive charge of the nucleus has to be equal to the negative charge of the electron cloud outside of the nucleus. In other words, very important to remember that the total number of protons in an atom must equal the total number of electrons in an atom. In other words, the total positive charge inside of the nucleus must be equal to the total negative charge outside of the nucleus. And this is an important property of an atom. An atom, by definition, must have an equal number of protons and electrons such that overall the atom is charge neutral.